Hi viewers, welcome to module 2 of probability and statistics, where we will discuss descriptive statistics and discrete distributions. Concepts are mean, median, mode, which are about central tendency, variancy and correlation, discrete random variables, binomial and Poisson distributions. Coming to module 2 topics, let us see the agenda. In case of central tendency, we will see three measures. One is mean, second is median, and third is mode. And in case of studying spread of data, we will see variance and standard deviation. And in case of relationship between two variables, we will see correlation and covariance. And in case of discrete uh, functions and discrete random variables, we will see random variables and the probability mass functions. And in case of distributions, we will study uniform, Bernoulli, and binomial distributions. First of all, we will see measures of central tendency. In measures of central tendency, there are three metrics. One is mean, second is median, and third is mode. First of all, when the data is symmetric, that means it is distributed in a consistent way and there are no outliers. In that case, we will use mean. Mean is defined as arithmetic average of all values in the data. It is represented by mu symbol. For example, if the data is 2, 4, 4, 6 and 8, then mean will be sum of all the data points by number of data points. That's why we are dividing 24 with 5 and we are getting 4.8. Coming to the word outlier. Outlier refers to a data point which is extremely smaller or larger than the remaining data. That means it has very unique properties and its properties are very far from the remaining data. For example, in normal human population, gens will be 5.5 to 6 feet height. Women will be 5 to 6 feet or 5.7 feet height. If a person like Prabhas, Gopi Chand, or Hrithik Roshan, or some tall people can exist, but they are very few. For example, people who know about wrestling sport, a person called Kali is there, who is, I think, more than 7 feet. So such kind of data points are called outliers, which are not fitting with the regular data or regular population. Coming to the second metric, median. Median is used when the data is skewed. That means it is not bell-shaped curve. It will be more towards one side of data and very less data points are located on the other side. In that case, we will use median metric. For calculating the median value, we will initially sort the data points in ascending or descending order. Once we split in and once we order the data, sort the data, then we will pick up the central data point. If there are even number of data points, in that case, central two numbers average will be taken as the median value. Mode. Mode refers to the most frequent value appearing in the data. For example, in the data 2, 4, 4, 6 and 8, the most frequent data point is 4. That's why mode is calculated as 4. It is used when The data type is categorical data or multimodal distributions. Variance and standard deviation, which indicate spread of data. Population variance is represented by sigma square, that is variance, which is equal to sigma of xi refers to the data point minus mu. Mu refers to the mean value whole square by n. Sample variance. In case of sample variance, we will represent it using s square, which is equal to sigma of xi minus sample mean whole square by n minus 1. Here there are two important things that you need to note. One is mu represents population mean, x bar represent sample mean. And in case of population variance, we are dividing with n. In case of sample variance, we are dividing with n minus 1. Even the representation also, population variance is represented by sigma square. Sample variance is represented by s square. Okay. And below are examples for step-by-step calculation, how we will calculate the mean value initially, and then deviations square. That is a difference from the mean value, and then square. Once we get the square differences from the mean, we will sum them, and then we will divide with the number of data points if it is population variance, or n minus 1 in case of sample variance. Coming to interpretation and analogy, if sigma is small, that means data is clustered near the mean. That means more data points are located around the mean. That means we can't find much difference between the data points, and all of them will be located near the mean. If sigma is large, data will be spreaded out. That means more variation in the data we can see. One person height will be quite different from the other person height in case of our earlier discussed example. Analogy. For example, you can see average distance of students from classroom center. That means uh, we can study the marks scored by students. Coming to correlation and covariance. Generally, if we have some data or some features, we generally study the covariance, that is how they are moving uh, with reference to one another, and correlation, how this um, variation is seen when from the standardized point of view. Okay, so in case of covariance, it is represented as covariance of x y, which is equal to expectation of each random variable minus their mean into second random variable minus its mean. That is, we are looking at the covariance, how they are moving, which is equal to expectation of one random variable minus that random variable related mean into second random variable minus second random variable's mean. The sign indicates direction here, and magnitude indicates the severity with which they are varying. If the covariance is greater than 0, that means x and y are increasing together. That means, example, if you see, um, if silver and gold are positively correlated, in that case, if silver increases in price, then gold price also increases. If the covariance is 0, sorry, less than 0, that means They are negatively correlated, sorry, covariance. They have negative covariance, which indicates once the direction of one random value is in positive direction, then the second random variable will be in the negative direction. That means they will move in opposite directions. Coming to correlation, which is represented by or, there are multiple correlation coefficients, out of which one utilized is small r value, which is equal to covariance of x and y by standard deviation of x and standard deviation of y. Correlation coefficients are bounded by -1 and 1, which is standardized covariance. If r is equal to 1, it is perfectly positive. If r is equal to -1, perfect negative. If r is equal to 0, no linear relationship is existing between the variables. Analogy: if height and weight of people are considered as the features, in that case, if the correlation is plus zero point +0.7, in that case, it indicates taller people tend to weigh more. But it is not a perfect correlation. Temperature and hot drink sales are is equal to minus zero point -0.8, which indicates if the day is hotter, fewer hot drinks will be sold. Shoe size and intelligence. Generally, shoe size and intelligence do not possess any kind of relationship. That's why the correlation coefficient is 0. Here, please note that correlation doesn't indicate causation. Ice cream sales and drowning rates are correlated, both driven by summer, but they are not at all related. Okay. Coming to random variables and probability mass functions. Discrete random variables and PMF. A random variable is a function that maps each outcome in sample space omega to a real number. A discrete random variable, it takes countable value, integers or finite set. Example x equal to number of heads in tosses, or number of people purchasing mangoes, a number of people who opted for Geo or Airtel in telecom services. This kind of scenarios where the random variable will pick up discrete countable values. It doesn't have any continuous values. Okay. I mean, I can't say that 1.5 people have opted for Reliance Geo, or 2.6 people out of 100 have opted for Airtel. So discrete random variable is a function that maps each outcome in sample space to a real number. And probability mass function. In case of probability mass function, the probability of a random variable being equal to small x, that is for each possible value of x. Coming to properties, what is the probability of x being equal to x being greater than or equal to 0? Sorry, probability of a random variable x being equal to x will be a positive value, or frankly speaking, non-negative value, and more accurately speaking, non-negative value. The sum of probabilities of a random variable being equal to x will be 1. That is, all probabilities will sum up to 1. PMF of x being equal to heads in two fair coin tosses. So probability of a capital X being small x, where x value will be 0, 1, 2, etc., will be as follows. The probability of heads being equal to 0 is 1 by 4th. The probability of a number of heads in two fair coin tosses being 1 is equal to 2 by 4, and the probability of number of heads in two fair coin tosses being 2 will be 1 by 4th, and thus expectation of x, that is number of heads in two fair coin tosses, is equal to sigma of x into probability of a random variable being x. Thus it is 1.0, and the variance of capital X will be expectation of x square minus expectation of x whole square. In that case, it will be 0.5. Coming to section 3, that is discrete probability distributions. See, in case of probability distributions, we will see the distribution of probability among different outcomes. Discrete, uniform, and Bernoulli distributions. In case of discrete uniform distributions, all outcomes are equally likely. For example, if you are tossing a coin, 50-50 chances are there. Heads and tails are discrete and they have equal probabilities of occurrence. Thus, it is discrete and uniform distribution. Here, probability of a random variable being x is equal to 1 by n for x belonging to x1 to xn. In case of tossing a coin, heads and tails, that is x1 will be heads, x2 will be tails. Only two outcomes are there. In that case, probability of x being heads or probability of x being tails will be 1 by 2. Mean will be a plus b by 2. Variance will be b minus a plus 1 whole square minus 1 by 12. Example cases are fairy die where x belongs to 1 to 6. And coming to Bernoulli distribution, it is a single trial with the two outcomes, like heads and tails in case of tossing a coin. A single trial is involved and two outcomes are possible. Or attempting an examination where success or failure are the two possible outcomes. Thus, x random variable being success or 1 or heads will be probability of p, and x being the other value will be probability of 1 minus p. Thus, probability mass function will be given by probability of x being small x is equal to small p, that is probability of success, into 1 minus p, that is failure probability, power 1 minus x. And the mean is probability of success and variance is probability of success into probability of failure. An example is single coin toss. Now, coming to binomial distribution, which is represented by capital B, N, comma P. Here, N represents number of trials fixed in advance. Small p represents possibility or probability of success. K is number of successes. Mean value is N into P, expected success. Variance will be NP into 1 minus P. A simple analogy for this binomial distribution is A basketball player with probability of 0.7 shooting probability takes 10 free throws. In that case, capital X from a binomial distribution of 10 into zero point 0.7 will give a probability of exactly 8 baskets is equal to C combinations of 10.10 into 10 comma 8 into zero point 0.7, that is probability of success power 8 into failure, and here it is zero point 0.3 whole square, which will be equal to 0.233. Let us work out a gate style problem on binomial distribution. A fair coin is tossed 6 times. Here we have to find probability of exactly getting 4 heads and probability of at least 4 heads, and then mean and variance of the probabilities. Now, x is a random variable which is from the binomial distribution capital B, where the number of attempts are 6 and probability of success is 0.5, represented by n is equal to 6 and p equal to 0.5. Combinations of n of k, that is n factorial by k factorial into n minus k whole factorial. In case of a probability of x being equal to 4, that is getting 4 heads exactly, will be combinations of 6 is the number of attempts and 4 is the number of times heads is required, into zero point 0.5 all power 4 into zero point 0.5 whole square, which is equal to 15 into 1 by 64, which is equal to 0.234. The similar way, probability of getting heads at least 4, which mean 4 are equal. And one more thing, we have to find the mean. Expectation of x is np, which is equal to number of trials into probability of success, 6 into 0.5 and so 3. Variance is equal to variance of x equal to n into p into 1 minus p. That will give 6 into 0.5 into 0.5 is equal to 1.5. Sigma, that is standard deviation, is equal to square root of 1.5, which is approximately equal to 1.22. Now coming to end of module 2, let us revise what the concepts we have discussed till now. Mean is represented by mu, which is equal to the observations sum by number of observations. Variance will be equal to sigma square equal to sum of the random variable minus their mean whole square by n. Standard deviation is equal to square root of variance. Covariance is equal to expectation of variable random variable minus its mean into second random variable minus its mean, and correlation is equal to covariance of x and y by standard deviation of x and standard deviation of y. Bernoulli distribution is defined by probability of capital X being small x is equal to probability of success into probability of failure power 1 minus x, where mu is equal to probability of success, variance is equal to probability into probability of probability of success into probability of failure, and binomial probability mass function is represented by capital P of capital X equal to K is equal to combinations of n comma k into p power k into 1 minus p whole 1 minus p power n minus k. Binomial related statistics are mean is equal to n into p, where n is the number of trials and p is the probability of success, and variance will be equal to mean into 1 minus p, that is number of trials, probability of success into probability of failure. Thank you for your support and thank you for watching. Please subscribe for future videos, and I'm going to provide all the concepts related to data science paper for GATE 2027, and I will discuss past questions and material from obtained from different standard areas. Thank you.